Hey, so it's Issa with Journey to Programming again. I wanted to go ahead and continue on where we left off in the part one of this tutorial for the implementing simple game mechanics for the 2D platformer that we've been talking about. So where we left off earlier is we began today by going over the Unity inspector or the Unity editor window, which I'm hovering over right now with my mouse. We went over what these windows each are, how to use them in a brief discussion, and then we went into implementing the basic detection of the keyboard and applying it to a player game object in a Unity scene, right? So moving on from there, what we had discussed in our part one of this series of implementing simple game mechanics for a 2D platformer is we talked about implementing the detection of either the keyboard or a Xbox 360 controller and allowing that input to be applied to a player object. In this case, and the case of our original discussions, we talked about applying it to a cube as our player, and we talked about using or detecting left and right input, the ability to jump, and applying the ability to fall or move downwards, right? So far, I've given you guys some code already to detect keyboard input of specific keys using the Unity APIs for detecting keys on a keyboard, right? So that would be using the Unity API method called getKeyDown. And the way you do that is you say input.getKeyDown within an if statement. And if you place that in your update loop, then on each frame, the engine will look for input. If it detects input, then it will try to enter that block of code and execute whatever you've placed in there. So if we look now at the script that I created on the first portion or the first version of this video, then you'll see here that we have some basic code for a simple movement controller where, like I just said, in the update loop, I've added an if statement for input.getKey, which originally I used getKeyDown, but at the end of the video, I showed you guys how to apply input detection continuously by using the getKey call. And by using the getKey call rather than the getKeyDown, getKey will continue returning true so long as you are holding the key down. In this case, I'm detecting the keycode.A, which is the A key on your keyboard, which is part of the WASD keys, which are traditionally used in games for movement. So what I implemented for you was a really simple detection of if the player's pressing the A key on their keyboard, then let's go ahead and move the game object that this script is attached to 1 unit to the left per frame, right? So this is going to actually be really, really fast because again, this is happening at in the update loop where that is basically per frame. That could be running anywhere between 5 frames per second to 100 frames per second. Basically, it's dependent on your computer's capabilities or the actual computation time. So if we wanted to buffer this to make it a little bit more smooth, there are techniques like using the time.delta time, which is the time between frames, in order to allow us a little bit of an ease between how far our game object is going to move in between each frame. And that creates a little bit more of a smooth mechanic as your object will be moving. But we're not going to talk about that right now. Right now, what I want to do is I want to show you guys how to take this code and create the next input.getKey calls to detect left, right, and spacebar detection. Okay, so if you watched the first video in this series, I showed you how to do this, and then I asked you to go ahead and try implementing the remainder of the challenges that I asked you to do in the first release of this series, which was just a high-level talk on the road. And what I had asked you to do was go ahead and create the movement, moving left and right, add the detection, or implement the method calls, and just put some placeholder code in it for now. And if you did that, great. I applaud you. If you didn't, but at least you thought about it and you tried, then great. There's nothing wrong with that. If you got stuck along the way and you decided, hey, I'm going to wait for a tutorial, then hey, there's nothing wrong with that either, okay? That's why I'm here. I want to make sure you guys learn this stuff and have the support you need to keep on learning, okay? So what I'm going to show you now is how to reuse this code to detect the D key on the WASD keys so that we can move our player object to the right now. Okay, so if we look at the current code that we have, what it's doing is it's saying if the input.getKey method is true, then go ahead and execute this line of code here. And the way this will be evaluated is we're telling the compiler and Unity to say, if the user or the player is pressing the A key down, then that's going to evaluate to true. Therefore, our if statement will be true and will enter this block of code here, surrounded by these curly brackets, ending here and starting here. Now, if we take this exact same code, and all we do is we change the key code, then what we can do is we can reuse the same exact code and apply it to the key code for the D key, which will be movement to the right in this case, because we're using WASD, which is a very, very common way to move in video games. Then we should very simply have the code already for making our player move to the right. So there you have it. What I've done is I've reused this same functionality that I wrote up here. Remember, these two lines here are commented out debug lines that I created when I was first showing you that using this statement would successfully detect keyboard input. And since then, I've commented it out, and I've implemented the actual movement by manipulating the transform component of our game object. Remember, the transform component, if we look at our game object, which is the player, we named this in the first episode of this series, in the first tutorial episode. If you look at our player object and you want to find the transform component, you have to go over to the inspector window. It has the inspector tab here. Normally it's going to be on the right hand side of your screen in the editor. This is a Unity editor. And then you go into here and look at the transform component. What we're doing in this source code is we're going to that transform component, and what we're doing is we're basically manipulating the position data. The position data being the X, Y, Z here. So here's the X value of the position, the Y value, and the Z value. And the way we're manipulating it is we are adding a new vector 3 to our position value. Every time that this successfully validates to true on every frame. Okay? So if I run this code, and first of all, you can tell that it's been saved because these are the new lines that I've added here. They're denoted in Visual Studio nowadays with a few sets of lines on the vertical here. Yellow means that they have not been saved. It's new data. Green means that it has. I just hit Control S. I'm going to go ahead and undo that because I don't really need there to be a bunch of blank lines in there. I'm going to go ahead and save. Now that's a little bit more clean. And I'm going to go back over to Unity. When you save in Visual Studio, it should, when you move over to Unity, go ahead and hot compile or hot load that source code into the engine by auto compiling it. I sometimes will go ahead and manually call the build solution functionality in Visual Studio, which you can do manually by going up to the build button and hitting the first button that shows up there. It's build solution. In case it's not showing up within this video capture, it can also be called by using the Control Shift B hotkeys. That's what I normally use because I've been using Visual Studio for a long time. You'll see that it compiles. I have no errors, no failures. It actually did succeed, thankfully, woohoo. And then I'll go over to Unity and I'll press play. And right now I should expect that my code's going to work. So I should expect that if I look at my cube here in the scene view from far away, and then I put my mouse in the game window, and then I click the game window has focus so that it has focus. If I use the right key, which is D on WASD, my cube should move right. So if I click the right key button, which I'm doing now, you saw my cube move to the right. If I press left, it moves to the left, right, left, right, left, right, left. Awesome. If I move my cube off of this ground platform, you see that it drops. Why does it drop? I talked about it in the first episode of this series. It's because I've added this rigid body component to my player cube, which again, as I mentioned in the first episode, the rigid body component adds physics to your game object. So Unity, the power of using a game engine like Unity is that they already include a physics engine in their base source code and their normal tool set that they give you. So in this case, by adding the rigid body component, I'm basically saying that my cube game object, which is my prototype player game object, now can have physics applied to it, and it by default has gravity turned on, which you can see here in the actual component is denoted by the use gravity checkbox here. It's turned on by default. I've left it checked on. That way my cube is always trying to fall towards the floor. Luckily I have the ground there to catch it. And that's why you saw my cube fall off the edge there. All right, so now going back to the source code. Because we've written source code that detects the A key, the D key, I can move left and right. The next thing I want to do, which is what I asked you guys to do in the first high-level discussion about this implementing simple game mechanics discussion, is I want you to now detect when you press the spacebar key. So the way I'm going to do that is I'm going to use a get key down rather than just a get key. And the reasoning for that is going to be, let me just explain it in a minute, 1 second. The reasoning for that is I don't want to continuously validate true that I don't want to continuously enter this block of code as long as I'm holding the spacebar button. Instead, I only want this code to run once on the frame that the computer detects I've pressed the spacebar button down. So that's why I've chosen to use get key down rather than just get key. In order to detect the space bar button, I've used keycode.space. And because in this case I want to apply some jumping effect to my player, what I'm going to do is I'm going to do what I suggested as a prototype jump functionality really early on in the high-level discussion that we had a while ago. And I'm just going to displace my game object on the y-axis. So what you'll end up seeing is that when I press the spacebar button, my player game object is going to teleport on the y-axis upwards in the positive direction, which would be upwards. And this will be instantaneous. He will just, or not he, the cube will just move upwards. And then once that's occurred, you're going to see it go ahead and drop back down because we have gravity being applied to the game object. So let me go ahead and add the code to allow my game object to go ahead and do its magical teleportation on the y-axis. Here we go. So the way I'm going to do that is I'm going to apply nothing on the x-axis. I'm going to apply an offset of, let's say, 20 units on the y-axis and nothing on the z-axis. I'm going to go ahead and save my source code, and then I'm going to go ahead and run back into Unity, press play, and now I can see my cube here in the editor window or the scene view. I'm going to kind of fly right into it. And now I'm going to click on the game window, and I'm just going to hit the space bar. So if you paid close attention, you're going to see that my cube teleported from here where my mouse is up to somewhere towards the top of the window here. Let's go ahead and press space bar. Here we go. Maybe you can hear it in my mic. And there we go. So it may not be the most eloquent implementation of a jump mechanic, but the whole point of that is I wanted you guys to go ahead and implement the basic functionality behind detecting keyboard input. So that what you can do is, at this point, you can begin polishing that functionality. Sure, you may want to create some sort of linear ease of your player, so maybe instead of just teleporting like this to the top of the screen, maybe you want your player object to kind of do a nice movement, a nice upwards movement like that, and fall back downwards. Because a normal jump may have you actually easing up and down. Well, you just saw my cube go crazy. That's because of my rigid body component, and I'm playing and I'm moving it manually in play mode. Forget that, just keep listening. And you may want to have a nice linear ease where your box goes up under control and comes back down to the ground level. Or you may want to do something like a linear interpolation where maybe it eases upwards at a sine wave type rate, where it increases at kind of the midpoint and then drops back down. But really, that's all customization that can be done after you guys have learned how to detect this input and how to apply a change based on the event occurring, which is the detection of your input. So at this point, you can detect user input of specific keys. What I wanted to show you next is one other way of detecting input, and that's going to be detecting input on the horizontal axis and technically the vertical axis using a Xbox 360 controller. So if we look at our source code here, what we're using the input.getKey methods and the input.getKeyDown methods. Those are great. There's nothing wrong with it, but as they are now, they're very hard-coded to only detect the keyboard input. So there's a nice utility already available in the Unity input class. It's a method called getAxis. By using getAxis, you get to use the input mappings, which you can find. Let me go into the engine. You should be able to find, if you go all the way over here into, let's see, the edit file or the edit menu, and then one minute here. I'm trying to track down exactly where they've placed this sub menu here. So usually it is underneath the input options. Let's see. Here we go. So if you go to edit and project settings, and I am using Unity version 2018.3.0 F2, where this is now underneath the edit project settings window and then input. If you go ahead and look at this window, I'm going to go to expand it for you guys and open the drop down or expand it. For axis, you'll see that there's already two definitions in here which are going to relate to the source code that I begin writing. There's horizontal and vertical. What this allows us to do is detect input on the horizontal axis, which can be the A or D keys on the keyboard, the left or right arrows, or the X axis on a joystick, like an Xbox 360 controller. So these can be remapped, and you can go ahead and do that using this project setting window when you're ready to. In the beginning, though, where we are right now, we're going to skip remapping any of this input data because this is the default setting for Unity and it works pretty well. So instead, we're going to keep this at its default settings, and we're going to go ahead and begin detecting input using these settings rather than a hard-coded key code sequence from the keyboard. And we're going to do that specifically for the horizontal axis, so we don't have to detect keyboard input here explicitly, and we can just use a more generic detection method call, which is going to be the if input, which is going to be written like this: if input.get axis, within the parentheses, I'm going to have horizontal written out, and I'm going to say is not equal to 0, then do something. In this case, what I'm going to do is I'm going to have it print detecting user input. Now we're going to rewrite this in just a minute, but I want to show you how this ends up working. So I'm going to go ahead and turn on my Xbox 360 controller. I already have it hooked up to my computer right now, and I'm going to show you what happens when I hook this up when I'm just working already in the Unity editor. So I'm turning on my controller right now. It's blinking. It should connect in a minute. Let's see if it connects. It may not connect. Let me go ahead and just set this up really quickly on the device manager. So if you're looking over here, my device manager seems to not be missing anything. I can see the Xbox 360 peripherals showing up here. So let me go ahead and just resynchronize my controller. I just went ahead and disconnected and reconnected my wireless receiver, and there it went. It connected right up. Excellent. So when you connect an Xbox 360 controller to Unity, and Unity is running in the background, once your controller is actually synchronized with your wireless receiver, or if you're plugged in over USB, once it's actually connected to your computer, Unity will automatically detect that a joystick has been connected. It'll give you a debug log, and it'll tell you which driver it's using. Usually that kind of gives you an idea of what kind of controller you're using too. So with this input.getAxis call, what's going to happen is anytime that we detect axis on the horizontal axis, which is based on how it's mapped in the project settings that I showed you here. So horizontal, it's the left and right, and it's going to be using the keys, mouse button, or x-axis, and the joystick, okay? Man, that may have sounded confusing. I apologize if it did. I'll clarify it later if it did cause any confusion there. But if I press play now, just with that source code, what we should see, if I press the left key, which is, I'm going to use the left arrow right now, we see that it's detecting user input. I pressed it for a split second, but it's in an update loop, and you can see it's already debugged 24 times. If I tap the A key, which is a WASD key, the D key, or now I'm using my Xbox 360 analog stick and holding it to the left and right, and you can see that it's detecting input almost instantaneously. Same thing If I go back to the keyboard, Unity, by using that method call in the input class, automatically knows how to detect the Xbox controller, which is pretty cool. So if you're making a game and you want to make a 2D platformer, you probably want to set it up so it works with joysticks. This gets you so much closer to being there that it's pretty amazing, because this could have taken you hundreds of lines before we had all these libraries and game engines readily available to you. So now I'm going to go ahead and stop the engine and go back to our source code. And like I said, I'm going to rewrite this functionality that we just wrote. You can see that I commented out the hard-coded get keys that we did earlier. They're here. I'm going to add a little bit of space here so that we can rewrite this. And the way I'm going to rewrite it is I'm actually going to assign a float to this method call. So if you scroll over input.getAccess, the call right here where my mouse cursor is, it gives you the method signature and it gives you a little bit of data. So this method returns a float, and it's specifically the value that is being returned. So you can imagine that this is either going to be -1, meaning that you're currently holding your analog stick to the left, or you're pressing the A key or the left arrow. Negative left standing for you're moving in the negative direction on the horizontal axis. Or it's going to give you a 0, or it's going to give you a +1. 0 being there's no movement being detected, +1 being you're moving to the right or in the positive direction on the horizontal axis, okay? So what I'm going to do is I'm going to say float x is equal to input dot get axis on the horizontal. Then I'm going to say if x is not equal to 0, then I want to do something. So the reason I'm doing it is I just want to go ahead and cache my x value at the beginning of every frame, so that if I'm calling it a bunch of times below there on that same frame, I'm not calling the entire input.getAccess method, which maybe it's not going to do a lot of computations in between there, but it still has to call a method, and then it has to translate a defined input. And all of these things have a little bit of overhead. I may as well just cache the value, and I'm just going to reuse that within this block, okay? So it's just a very simple kind of optimization that we're doing there, but I highly recommend it so you don't have to keep on making that long method call. It also simplifies the amount of text you're writing. So now to apply this value to my game object like we were doing before, I'm going to take the original code that we wrote, and I'm going to apply it to my x, or I'm going to apply it based on the direction in which my x value is pointing. So if my x value is less than 0, then I know that I am holding the left button or pushing the analog stick to the left. And therefore, I want to move my player to the left by manipulating its transform.position with a negative x direction. Else if my x is greater than 0, I want to go ahead and tell my cube to move in the positive x direction. All right. So I'm going to go ahead and remove the do something comment and the print statement because we know this function works. And instead, I'm just going to go ahead and see if my new code works with my Xbox 360 controller. Now, we know that it may be really fast because once again, I'm not buffering my movement units by my time.delta time, like I mentioned earlier in this episode, but we'll still be able to see it move. I'm going to go and expand my scene view here so you have a little bit more view of the overall and high-level picture of what the scene looks like right now. Here's our cube, and here's our game window where you can see what the camera is actually seeing. So our camera's sitting here. These are the kind of the max angles that the camera is seeing right now. And then I'm going to go ahead and hit play and see what happens. So I've clicked within the game window to give it focus, and I'm going to go ahead and begin using my analog stick on my Xbox 360 controller. So here we go, left, right, there you go. All right, simple enough. I'm going to go ahead and move to the keyboard. You can kind of hear me pressing the keys in the background. So I was using the arrow keys, and now I'm going to go ahead and use the WASD keys. There you go. And with that, we're now able to detect any movement on the horizontal axis, whether it's from a keyboard or a controller, by using the input.getAxis method call. If you want to detect movement on the Y axis or on the vertical axis, so for example, you want to detect W and S input, or up arrow, down arrow input, or up and down movement on the analog stick from your joystick, then you could use, instead of input.getAxis horizontal, you could use vertical with a capital V. And what you would want to do there is you'd potentially, if you want your object to move upwards on the Y-axis, then you would manipulate its Y-axis values in the offsets you're using for its transform position. Or if you wanted to move forward and backwards on the Z-axis, you'd apply it to its Z values. So with that information, I'm going to go ahead and leave you guys there. I'm not going to give you guys the next pieces of code to implement it using the vertical axis. I'm going to let you guys jump ahead and do that. But I challenge you to go ahead and try reusing the code that I've given you now, and try applying some sort of input detection of the vertical axis of your controller, whether it be just making a placeholder on reading the method call, or creating the method call and putting a placeholder in there where you're just reading input detection and doing a print log to show that you're getting input detection working. Or maybe you want to add depth to your project and you want to go ahead and make your ground object not just a 2D plane or a 2D or a cube that's been only expanded on the x-axis. Maybe you want to expand that ground floor on the z-axis too, so that your object can move forward and backwards. Either way, I encourage you to go ahead and try experimenting with this and have a little bit of fun. We'll have another episode out where we actually show you how to apply the vertical axis, how to detect the vertical axis, and then how to apply it to an object to move forward and backwards. And then also we're going to begin playing around with platforms on the next tutorial video, which will go along with the high-level discussion we had before that. Good luck with your programming. If you have any questions, just go ahead and send us an email and check out the blog at journeytoprogramming.com. Have a good one, you guys.